Thanks, sir, for this honor. Now I would like to invite Noman Irshad from Mehran University of Engineering and Technology, Pakistan, and the title of his presentation is Precipitation Trend in Balochistan Under Changing Climate. Noman Irshad, please. Please unmute yourself. Numan, please.
Hello, am I audible?
Numan, can you hear us?
Yes, sir.
Yeah.
Sir, am I audible now?
Yes. Numan, please complete your presentation within 5 to 10 minutes. Thank you very much.
Okay, sir.
You can carry on. You can carry on.
Okay.
Thank you.
I am Noman Irshad, and I will be talking in this presentation about precipitation trends in Balochistan under changing climate. These are the contents of my presentation, and now comes introduction. As we are short of time, so I am skipping this section. Now, the main objective of this study is to predict the future precipitation trends in Balochistan based on the Cardex South Asia data under changing climate. Now comes methodology, and this is the methodological flowchart in which we have downloaded the Cardex data of two GCM's global climate circulation models. The data was precipitation data based on the monthly time series. The data was for the historical time period and for the future time period. For the future time period, there are two RCP scenarios, RCP 4.5 and RCP 8.5. Now, the data from historical and future scenarios has been biasly corrected by the method of distribution mapping. And then the mean of the both models means biasly corrected data of the both models have been incorporated in this study for the analysis purpose. The historical time period is for 55 years, starting from 1951 to 2005, and the future time period is 75 years, starting from 2026 to 2100, and two RCP scenarios. And these are two models we have taken from Cordex South Asia domain. Now, using MATLAB, the Cordex data is interpolated at 12 gauging stations, which are handled by PMD, located in the province. The map at the right-hand corner is showing the location of these PMD stations points. The precipitation trends are analyzed at these points. Now, this is the map of the study area. The Balochistan is the largest province of the Pakistan, covering approximately 45% of the area of the Pakistan, and this is the dry and mountainous province of the Pakistan. Balochistan receives 200 to 350 millimeters of the precipitation annually. Now comes results and discussions. In north of the Balochistan, the graph means the figure 3 shows that the mean monthly precipitation shows that the precipitation starting in the starting months January, February, and March seems to be decreased in the future with reference to the historical period. In September, October, and November, the precipitation is expected to be more than the historical one. And in the south Balochistan, the precipitation in January, February, and March, April, and May is expected to decrease as compared to the historical one, as we can see from these graphs. And from May to November means from May to November, the precipitation is projected to increase in the future. Irrespective of the region means both North Balochistan and in the south of the Balochistan, the peak of the monthly mean precipitation seems to be in the month of July. Either in the North Balochistan or in the South Balochistan, the peak precipitation is in the month of July in both historical and both future scenarios. Now, at Barkhan stations, Barkhan, Khuzar, and Zob stations, the precipitation trends are increasing, means positive trends. These are the graphs, means black series is showing the historical one, the blue series is showing the future for RCP 4.5 scenario, and the brownish series showing RCP 8.5 scenarios. The column 1 is for Las Bela, and second is for Gwadar, Koita. Now comes Panjgur, Turbat, Kalat, Uthal, Barkhan, Dalbadin, Nokundi, Khuzdar, and Farzob station. Now this is the summary of these graphs, and all this means we at the in the blue color there is positive trends, means precipitation is increasing, the trend is increasing, and in the light reddish color the precipitation is decreasing, means negative trends. We have one station we have one station Turbat, which have the negative trends in both historical and future scenarios, means the precipitation is decreasing from the starting of the period till the ending of the analysis period. And we have the stations Barkhan, Khuzdar, and Zob stations, in which the trends are positive for the all three scenarios: historical, RCP 4.5, and RCP 8.5. At all stations, the value of average annual precipitation is different in different years. The peak value obtained at every station in the historical period and the expected peaks for both future scenarios are shown in the table number 2, which is shown below. How comes conclusion? It was concluded that in Balochistan, the precipitation in future is predicted to be less as compared to the historical one in January, February, March, and in the December month. No shift of the peak precipitation was seen between the historical and the future scenarios. The peak precipitation is expected to be in the July month, which is same in the historical one. At a few stations, there is an increasing trend of precipitation from historical to RCP 4.5 and from RCP 4.5 to RCP 8.5 and vice versa, as I shown in the table. Some stations show that increasing trends in the Balochistan period, but trend is expected to be decreased in both future scenarios, means RCP 4.5 and RCP 8.5 scenarios. All the stations have received once the peak precipitation in the past, and expected peaks at all stations for both scenarios has been calculated. These are the references of my study. Thank you.
Thanks for discussing a very important topic that is really a need of time.